Welcome to The Explainer. Today, we're going to pull back the curtain on the internet itself. We're going to explore the incredible, invisible highway that your data travels on every single day. Think about it. You hit send and boom, it's just gone. It feels totally instantaneous, doesn't it? But in that tiny fraction of a second, your data kicks off this wild journey through a hidden world of hardware. So let's follow just one little piece of that data, we'll call it a packet, and see exactly where it goes.
Okay, so every journey has to start somewhere. For your data, that journey begins right there, inside your own computer, at the physical front door to the entire digital world.
So, say hello to the network interface card, or as most people call it, the NIC. The absolute best way to think of this is as the departure gate at an airport. This is the specialized piece of kit that translates all the digital information from your computer into electrical signals that can actually zip down a network cable.
This little piece of hardware right here, it's basically the unsung hero of connectivity. And it doesn't matter if it's a separate card like this, or just a tiny chip built right onto your phone's motherboard, every single device that connects to a network has one. It's the universal translator between your stuff and the vast digital world out there. All right, so our data packet has its boarding pass and it's officially left the gate. But now, before it hits the open road of the internet, it has to navigate the busy local traffic of your home or office network.
You know, back in the early days of networking, the first stop for our little data packet would have been a device called a hub. Hubs are, well, they're simple. They connect computers together, but they're not very smart about managing the conversation.
And here's the huge problem with a hub. Let's say your computer wants to send a message just to Sally's computer. The hub doesn't know the difference. It just takes your message and shouts it out to every single computer connected to it. It's literally like being in a crowded room and just screaming to get one person's attention.
This whole shouting match creates what's called a collision domain. Just think of it like a single party line on an old phone. Only one device can talk at a time. If two try to send data at the same moment, poof, their messages literally collide and get all garbled up. It's inefficient, it's slow, and it is incredibly noisy. So, to fix these constant network traffic jams, engineers came up with a much smarter device, the switch. Let's see how this thing completely changes the game. You see, unlike that shouting hub, a switch acts more like a clever postal worker. It actually looks at each data packet and it reads the specific destination address. That's called a MAC address, by the way. It's a unique ID every network device has. Then it creates a direct private line to send that packet only to where it's supposed to go. The difference is just massive. A hub creates one giant, slow traffic jam where everybody has to share the same bandwidth. A switch, on the other hand, is intelligent. It completely breaks up that traffic jam by giving each connection its own private lane. This means lots of conversations can happen all at once, making the whole network way more efficient and super fast. Okay, quick check-in. So based on what we've just seen, what's the key device that really manages all this local traffic in a smart way?
Exactly, the switch. By getting rid of that old bullhorn, the hub, and bringing in the smart postal worker, the switch, our modern networks can handle massive amounts of local traffic without just slowing to a crawl. Okay, our data packet has successfully used the switch to get around the local neighborhood, but now it needs to get out of town and onto that global information superhighway. This is where the router comes into play. If the switch is your local traffic cop, then the router, well, the router is the on-ramp to the worldwide internet. Its entire job is to connect different networks together. The router takes a look at our data packet's final destination address, not the local one, but the one that's way out there on the internet, and it figures out the best path to send it on its way. Without a router, your data would just be stuck. It would be trapped on your local network, never able to reach another city, another country, or another continent.
So let's just recap that entire journey. And remember, this whole thing happens in the blink of an eye.
So, it all starts at the departure gate, the NIC. Then it gets sorted by the local traffic cop, the switch. And finally, it gets onto the highway using the on-ramp, which is the router. These three pieces of hardware work together in this seamless, high-speed ballet to get your data delivered in an instant.
And really, that's the key takeaway. Even though we almost never think about them, this invisible highway of NICs, switches, and routers is the fundamental infrastructure that powers our entire digital lives. And understanding how it works really helps demystify the so-called magic of the internet.
And that's our explainer for today.
We've mapped out the physical journey of your data. But that leaves us with a really critical question. With all this data flying around all over the place, how in the world is it kept safe from attackers? We'll explore that next time.